Okay, hello, and welcome back to this stuff. I'm seeing again. Even with clean hair, like I washed it last night, but without the right cut, there's no changing this weirdness. I want to show you. Got the Christmas tree decorated, and then we did this secondary. My son's calling it the Hanukkah bush. I'm gonna try to explore some different cultures this year. I'm not sure if Hanukkah bushes are real or not, but it's real in my life. So there you have it, folks. There's the news from me. I hope you all are doing well. You can always send me things other than your quizzes. You can send me updates in your life or interesting images from your experiences. I'd love to see that. Today, I was going to do a final lesson on light and illumination. We didn't go over this much because it is fall crops, and most of our coursework is around outdoor production systems. But I've got plants inside now under lights. We've got hemp mothers for next year that we take clones off of. Those are growing indoors under lights. I've got some other cactuses and things under lights. At school, we'll have tomatoes under lights soon. So it's a big part of modern agriculture to understand this, and it's a big part of contemporary households to have some kind of lighted areas, whether it's for house plants or exotic plants or even food plants. So I think it's a worthy endeavor here. So looking at it in this perspective, I titled it Light and Illumination. Light being the noun of what we're calling the energy of light, and illumination is the process of bringing light to a place. So seeing and beyond the seen. One of the things that helps me focus my mind is to kind of consider the thoughts of others. In absence of being able to meet in class and consider your thoughts, and I'd like to get into conversation with other thinkers and writers. And this is from our very own Mark Twain. A lot of people have heard his name, but few people have actually read his stuff unless they were made to in high school. He's kind of a salty intellectual, man of the earth. He's considered to have these great witticisms. Like his quotes are very quotable because he had a knack for condensing a lot of wisdom and intelligence into very few words. Here we go. One. This is kind of like the boomers to millennials sort of vibe. I'm not trying to cast that on you, but check it out. Don't go around saying the world owes you a living. The world owes you nothing. It was here first. I think that's kind of helpful when we start to feel entitled. I have to go this route in my mind sometimes. Of course, his justification is that the world was here first. It's the planet is here long before you came into it, and you kind of have to follow by its rules. Of course, a lot of the rules we live by are made up by people and can be changed by people, which I think is worth respecting too. So, expecting culture to give you a living maybe isn't so bold or shameless. I'd like to hear what you had to say about that. Second one here, I like this one. I do not fear death. I had been dead for billions and billions of years before I was born, and I had not suffered the slightest inconvenience from it. And he's here equating death with just being inert, like the rest of the matter in the universe is just kind of atoms moving around, and they're not really worrying about things. Stars don't seem to worry. They don't seem to be inconvenienced by anything. So he's sort of suggesting that after you die, you just go back to being the stuff that you're made of without any of the suffering or inconvenience. Keep away from people. This is a good one. Keep away from people who try to belittle your ambitions. Small people always do that, but the really great make you feel that you too can become great. I think we kind of sense this sometimes, but if you feel like your ambitions are being belittled in the world, maybe check in with that. Check in with that feeling. Is it because your ambitions are ridiculous, or because you're not trying hard enough, or is it people around you kind of eroding your self-confidence and your self-love? Who knows? This one's classic. You might have heard this. If you tell the truth, you don't have to remember anything. Of course, this doesn't mean you don't have to remember anything, but if you tell the story that is imprinted in your brain as to what actually happened, you don't have to remember the narrative that you create in a lie. Like, liars have a hard time remembering all those things because they fabricated them. They didn't actually happen, right? So they had to kind of fabricate it in their mind, and then when they refer back to it, sometimes they miss the details. Judges are good at this. They'll hear your story and then they'll ask you some kind of unusual little questions about the story that don't seem to be very important details. I think some of that is them checking in with whether those details came from a lie or whether they came from your actual experience of the events. And the last one here, the difference between the almost right word and the right word is really a large matter. It is the difference between lightning bug and the lightning. So words are funny that way. You shift them a tiny bit and they come to mean something very, very different. Anyway, so getting back to this, remember the first day of class we talked about plants requirements. I think there were 6 that we agreed upon. Light being one of the more obvious ones. If anyone's ever put a plant in a dark room, within 3 or 4 days they'll turn very yellow and perhaps even white. If you've left something in the lawn, like a tarp or a box, when you go to move it days later, the grass underneath it's become pale. This is because plants need light. And we weren't able to bring artificial lights to plants until the 20th century, essentially. I don't know if there was natural experiments done to see whether plants can grow from like candlelight or something, but we never really had a way to test this requirement of plants, except you could dig up a plant and bring it inside, but we didn't know that what about the sun that it really needed, right? We didn't know what type of energy was being used in the photosynthetic process, and now we know that it's a specific kind of energy that we call light. Visible light, is on the electromagnetic spectrum, so it's this little tiny bandwidth between 10 to the minus 6 and 10 to the minus 7th meters. So that's like very, very small. Like 1 meter wavelength would be 3 feet or whatever. That would be the wavelength of the waves, and those are like radio waves. Are the longer wavelength waves. And down here you see X-rays. Those are what you use to make images of bones, right? See through your body. Infrared is like heat. We experience that as heat. You see that in like those. When I was a kid, when I was in high school, I worked at a fast food place, and we had like red lights that kept the French fries hot, and those are infrared lights. Microwaves are another form of energy that we use to heat water or tea, or we also use them in cell phone towers to broadcast signals. But so light is part of that spectrum. It's part of this energy continuum that contains all these crazy things. Yeah. So why do plants grow towards light? We just have a word for that. It's called phototropism, but it definitely has something to do with plants getting energy from the light and requiring it. And one of the ways that a plant will tip towards the light is because if you have a stem, and that's like my hand, the cells on the dark side of the stem stretch and grow longer and softer, whereas the cells on the light side of the stem stay shorter and stronger. So that tends to make the stems bend. If it's growing longer on this side and shorter on this side, it'll curve, and that curves it towards the light. And that happens pretty quickly. Sometimes it happens each day, like in a sunflower field. The flowers and the leaves will all track with the sun over the course of the day. Okay, so we have 3 ideas here associated with light. We have frequency, which is the exact wavelength. Going back a few, this would be the frequency would be this number down here. So the longer light, the reds, are a longer frequency light. It's measured in these nanometers, so 700. And the shorter frequency light is like the purples, even ultraviolet. So that's what we mean by frequency. So that kind of the color of the light would be the frequency. The day length is how long of light exposure is before there's a dark period. So the day length would be like right now our day lengths are close to 12 hours. So at no, sorry, our day length is 12 hours at equinox. So in the winter solstice, our day length is more like 8.5 hours. And the last one is integral. You probably haven't heard that one. I hadn't heard of it until I studied lighting. And this has to do with how much total light energy it gets in a day length period. So it's kind of a factor of how intense the light is and for how long. Okay, so this is sweet. Just so you know, photosynthesis isn't evenly distributed across all of what we call white light, or the total light spectrum. Photosynthesis is higher in this blue range, like 420, 430, and this red range. So these peaks mean the higher photosynthesis happens at these blue and red frequencies. And the depression here, the lowest amount of photosynthesis happens at the green wavelengths. And that makes sense, right? When we look at a tree or a plant, they seem green when they're growing well. And that means the green light is being reflected. It's not being absorbed, and therefore it's not being used by the plant. So that's part of the reason most of what we see in the plant world is green, because those are the unused parts of the wavelength. And this all happens in the leaves. Some plants have photosynthetic stems. Some roots can become photosynthetic. You pretty much know anything that becomes green on a plant would be photosynthetic, because chlorophyll is reflects green, and it appears green. You can check these out on your own. This is a pretty simple diagram. What's actually happening in the chloroplast is super complicated. It's been one of the great achievements of science was to kind of understand that process on a molecular level, but it's beyond even me to describe that to you. But back to what's interesting to us, the day length, right? So day length triggers a lot of factors in a plant's life cycle. Strawberries, like there's day neutral strawberries and there's June bearing strawberries. The June bearing strawberries are triggered by a certain day length in the spring, which makes flowers come out and then gives strawberries. Some strawberries are bred to be photo neutral or photoperiod neutral, which means they'll just put flowers on anytime they're healthy enough to do so, and they're not tied to the day length. Some plants, this is not a Photoshop thing, this is an actual cabbage. Look at the happy cabbage dad. Some places like Alaska, where in the summertime they have full length days, like it's light out for the entire 24-hour period, which is known as white nights, and that goes on for like 60 or 70 days in the Arctic zone. So some plants really respond to that. Cabbages were bred and developed in Europe, where the Arctic, where there was natural light and dark periods. But when you take this European cabbage up to Alaska in the cool temperatures but long length days, it just never stops growing. It never knows when to take a break. And I think the minimum weight of a cabbage to get into the Alaskan State Fair is like 70 pounds. Like I said, there's some other kind of physiological things in plants, like when to flower, when to create a bulb. These are all triggered by day length, or another word for that is photoperiod. Integral, I don't want to harp on that too long because we don't have a lot of time, but take a look at it. It just means the total light energy in a day, and most crops need 10, but some, like tomatoes, can use up to 40. And this shows you, this is a way to scope that out if you want to check that out in your time. Can there be too much light? The short answer is yes. This is like in deserts. Any place where there's way too much light, you see leaves become very small. And the spines on a cactus are basically small leaves. Here we go. These are what types of electrical lights we have in our indoor grow room. High pressure sodium, compact fluorescent, LEDs. and there's some comments on them. So take the quiz.